Hi everyone, today we are going to see my first POC on AWS data engineering. Here I have given the entire architecture in this diagram. We will have our upstream as CSV file which is about 5 GB of storage, and these files are coming from click events from the e-commerce website. So we will uh, we will we will store our CSV file in our raw zone of Amazon S3 bucket. Then we will uh, we will create an EMR cluster to initiate a Spark job, so that like we can do our aggregation and like data cleaning activity, aggregation activity, and partition activity, whatever the business requirement we want to achieve, we want to showcase in our downstream, so that we can show up. So post Spark job is completed through EMR cluster, we will store up the data into a gold zone of Amazon S3. Then we will move, then we will use AWS Glue Parler to get the metadata of these files, so that we can query the data in Amazon Athena SQL very uh, in an optimized way. And note that the target Amazon, like gold zone has Amazon S3 gold zone has Parquet format, so it is very much optimized, and we have made the partitioning also, so that like the Amazon Athena SQL can easily query this S3 through the AWS Glue catalog metadata. Okay, we will see um, our source file now. First, let's look at our upstream source data. This is 5 GB CSV file tracking user activity logs like sessions, click ID, product categories, and purchase amounts. It's heavy, uncompressed, and has many systematic errors, like uh, like a corrupted timestamp. So we need to push this into our S3 bucket in the raw zone. So let's move on to the console. So I'm just creating a bucket here um, in the Asia Pacific Mumbai region. So I'm just creating raw zone POC1. This is my bucket name. So I will go down. I will not enable versioning or any other thing. Just I'm just creating a bucket. So this bucket has been created. Now let's create one more bucket called gold zone. So in this gold zone, we will put our output data coming from our EMR cluster, processed data, right? Okay. Gold zone POC1. So I'm just creating the same thing. So our two buckets has been created. Now let me go into raw zone, and I will create one folder called input. So in this input folder, I will upload the CSV file. So I have my CSV file here. This is my user catalog, and it is about 5 GB. So this is the CSV file. I'm just uploading it. Now the data has been loaded into S3 raw bucket. This is 5 GB CSV file, which is the data is uncleaned and it is in semi-structured format. So now let's go back to this bucket and create a folder called scripts. Here we will upload our PySpark scripts, so that like our EMR will take the script from this particular folder and it will execute it. So before uploading it, let me give the code walkthrough here. So I have imported all my required modules and functions for this particular uh, code. Whatever modules and functions which are required, I have imported it here, and I have built a Spark session, uh, and then I have given here struct type. Like I'm explicitly defining the schema type. This is because EMR has to scan 5 GB CSV file twice just to guess data types. So in order to avoid that extra work of the EMR cluster, uh, we are just defining the type, like type of the file, like each uh, column name and what data type it holds. So next, we are reading the data from our S3 bucket. Wherever we have like this particular bucket we have created, and we have inserted our uploaded our CSV file, right? So we are taking it from here and reading it and storing it as a data frame. Then we are doing processing. Like I'm creating a separate column called event date. I'm ignoring the timestamp and just making it into a date. And then I'm again, like from the date I'm taking year, from that date I'm taking month, and storing it as a separate column for doing some kind of uh, activity, some kind of querying activity in Athena we can do, and we should do our partitioning as well. Okay. Now I'm making some cleaning activity here. So I want only the data for 2026, and HTTP status is equal to 200, and product category should not be a corrupted product category. So I only want a valid record. I don't want any corrupted record. So I'm making a filter condition here. So I'm doing a data cleaning activity here generally. Okay. So I'm taking my required columns and making some of the columns with aliases, so that like product category to category, action type to action, device type to device, purchase amount to revenue, so that I can get the in like I can query it in Athena easily and get the insights. Okay. And then we are writing it into a um, S3 bucket as a Parquet file. So we are writing it into this particular S3 bucket, golden zone bucket, um, this particular folder as a Parquet file, and we are doing a partition by event, month, and category, so that like whenever we are running query in Athena, uh, we will not scan the entire 5 GB data, even though it is compressed into a Parquet file. We will not scan entire data. Whatever filter condition we are giving, right? Based upon that, we will scan that particular partition alone. So our query performance would be high, and the cost will be less to retrieve those data, right? Instead of retrieving every data and searching into every data. Okay. So I am going to upload my script here, in the S3. Okay. I have my EMR job script here. So I will upload it. So it is success. So the script has been inserted here. Now I will go back to my buckets and go to my golden zone and create a folder called Clickstream Analytics. Here our outputs will be stored in a partition based upon these two partitions, event, month, and category. Many Parquet files will be stored based upon that. So let's go ahead and create a EMR cluster for this. So I'm going to create a new cluster. I will name it as POC1 demo. Okay. I will take some version of EMR, and I am selecting application bundle as Spark Interactive. So I will just leave it as default because I just need Spark here, Spark and Hadoop. Okay. So then I'm going to change um, this MX5 large to make uh, less less cost. I'm choosing this particular instance. For all the things I will give the same thing. Okay. Like this primary is our master node, and uh, and here you can see we have one core node and a task nodes. So I will leave it as only one core node, and task node I will give it as 2. So totally we will be having 4 node here, 4 node cluster. The primary node would be our master node, and these three are slave nodes. This core node will save the data, like it will process and save the data. This task node will do the parallel execution of the job, right? And it will store the data in this core node, right? Okay. Now I will leave this VPC connection and subnet connection as default. Uh, Here, I will just give a key pair which I have already created for this particular demo, and then I will assign a EMR service role. This is also already created, so we'll just use this one. And also I will assign this demo role EC2, demo role for EC2. This particular uh, role will have access to uh, access S3 bucket. So all the EC2 instances, right, like one master node and three slave nodes, will uh, will have its will have permission to access the S3 buckets. Okay. One more thing I have to give here, like I wanted to make this as a spot node. Now I'm just creating this cluster, so it will take some time. I will come back once the cluster is completed. So now the cluster is ready. Okay, like it's in waiting stage. So now we can go to, like, I will show you, like I have created these many clusters, and this is the cluster which I have created now. Okay. Now let's go to steps and trigger our EMR job. So I'm adding a step. I'm clicking into a Spark application. I'm naming it as POC1, and I will give this particular folder. Like this is our S3, right? Like this is our script, right? Which is located in the S3. So I will just give this particular script here, and we'll just click on add step. So the job is in pending state. It will run and it will get succeeded. Once it's get succeeded, we will get the records in gold zone. In this particular folder, we will get our output Parquet files in partitioned way. So still the job is running. So now the job is in running state. So you can see here like some of the partitions I've already created. Still the job is running here because other partitions will be created. So when it is running, you can see here like it has created month wise and category wise folders, partitions, right? So you can see each Parquet files over inside each and every partition. So as the job runs for all the months in our CSV file, we will get all the records here for 2026. So once job completed, yes, the job is completed and we got the success message, right? Okay. Now, we have to view this records in our AWS Glue. So let me go to AWS Glue service. Like we have to view this records in Amazon Athena, right? So for that we have to create a AWS Glue metadata catalog, because these files the Glue should, I mean the Athena should understand what is the metadata for these files, right? So that is the thing. So let me create it through a curler. So I will create a curler. So I will name this curler as POC1 demo. I will just click on next. So I will add a source. My source is nothing but uh, this particular S3 bucket. I've added a source. Next I will create. I will just give a default glue role, and then okay, I will just create a database for this. So I will name it as POC1 DB. I should name it in small letters. POC1 DB1. Okay. So I'm just creating this DB. So this is all created now. Now I will select, I will refresh this, and now I will select POC1 DB1. So just click on next. I'm just reviewing it. Everything looks fine, and I will just create a Carla. Now I will run it. See, this will create metadata so that our Amazon Athena will query the data inside our gold zone tables, gold zone S3 bucket, right? Okay. So it's still running. So meanwhile, I will take Athena. I will go to query editor and query settings. We'll just change this particular uh, bucket. So I'll go to POC1 gold bucket, and I will just click on it and choose this and save it. Now I will go to my query, refresh this, and this table has been created. Clickstreams analytics. Now I will just preview this table, so you can see the records is getting populated. The first 10 records I have reviewed here. Now let's answer some of the questions. So I have made the SQL query. So this is conversion rates and total revenue by product and category. By product category. Okay. Now I'm running it. See, like for all the records, right? It just took only 1.5 seconds, right? Approximately. So if you are scanning 5 GB of data, right? And getting this kind of record, it will not take this much of very much slow thing, right? So it has returned many records, aggregated, and it has returned it, but within 1.58 seconds. This is because how we have partitioned here, right? So month one, and even in that month one, each category has been partitioned here. That is why the lookup is very fast here. And the thing which we got in the output is like for home kitchen, this much click happened in our e-commerce website, and this much of sales we got, and this much of profit, like this much of gross income we got, right? So that is what we are getting from this particular inference. Like for each and every category we are getting that insights. So the next one is another thing I have built, another query. So this will return you platform traffic and device performance profiling. Okay. So see again 1.8 seconds only. So again we are doing some aggregations over 5 GB of data. Remember that 5 GB of data we are doing some aggregations, and it is giving us the results within 1.8 seconds. It's really nice, right? Because of that structure. We have made it uh, in our S3 bucket, golden bucket, right? So here you can see, like for desktop Chrome, for this particular device, we had this much of interaction, right? And then we got this much of average income, gross income, right? So this analytics, this insights also we are getting it. So by this, what we are achieving is the most important thing is like we have built a complete end-to-end data pipeline in uh, Amazon using S3 EMR, and we have viewed it in our downstream Amazon Athena using AWS Glue Catalog. And the structure of the file, the Parquet file, and it's a compressed columnar storage, and also our the way we have partitioned it makes our query very efficient. So this is what our POC. Thank you.